Right, the last piece of this section, um, we discuss when a derivative does not exist. And it turns out there are three cases that you can see right there. When will f of x, and you notice the language that we use there at the top, when f of x is not differentiable. So that word is a little tricky, differentiable. F of x is not differentiable at x equals a. You would think that they would say f of x is not derivable, right? It doesn't have a derivative, not derivable at x equals a. But that's not the language people use. They say not differentiable. And, that's the same language that we use for um, differential calculus. Okay. Really, all that means is that the derivative right there, f prime of a, is d and e. Okay. So there's three ways that your derivative cannot exist. So number one, there might be a jump there, and there's my first drawing. So if there's a jump, well, and you kind of make sense of it, with a limit. If a limit doesn't exist, or if it's not continuous, then certainly a derivative does not exist. Or maybe if you want to go even further and think of like tangent lines, you say, hey, if there's a jump, then on the left side here, if we were to draw the tangent line, it'd be going out this way. But on the right side, thinking coming backwards, the tangent line would be doing this. Well, if the tangent line over here does not match up with the tangent line there, then there's no derivative. It's kind of like a limit, like the limit, the left and the right sides have to be going to the same location. Well, for a tangent line, the left side and the right side tangent lines have to be the same tangent line. Okay, so no derivatives at a jump. Number two is kind of interesting. So we call this a cusp, C-U-S-P, at x equals a. And it's when there's this sharp edge, like this sharp corner, happening at a point. So here, this is continuous, right? So the function comes up, goes to that point, and then it just starts to drop off. So it's continuous all the way through. But there's this sharp corner and like this instantaneous change of direction right there. So it was going up. So if you were to draw the tangent line, and I've kind of done it already, the tangent line, thinking about the left side, would be continue to go up that way. That's the direction it's moving. But then in just an instant, the tangent line switches and is now pointed downwards, coming down this way. Well, even though it's going through the same point, that it's two different tangent lines, and so there's no derivative there at a cusp. Okay. And finally, there's this third kind of unexpected way, very unexpected way a derivative might not exist, and that's when there is a vertical tangent line at that point. So what I've drawn here is a function that certainly can come up, and it is not a very unusual function at all. Something that would do this sort of shape. Um, if you thought of the graph of cube root of x, cube root of x has this sort of shape. Now the point for cube root x is at the origin, but it's got exactly that same feel to it. So it's relatively, it's increasing, but it's relatively, mild, and then it starts to come up, and then it does this quick turn, and then a turn back, and starts to level back off. Well, right there where I've marked A, the tangent line is vertical. So I apologize for the shadows here. I had to turn my lamp on. Let's see if I can do this. So you can imagine tangent lines there, and then as you're getting closer to A, the tangent lines get steeper and steeper and steeper, and then right at that one instant at A, the tangent line goes perfectly vertical, and then as you start to come off the other side, the tangent line then levels back out. Well, why is this a problem? I mean, there is only one tangent line. That's true, and that's very different from these other ones. There is just the one tangent line. However, what's the slope of that tangent line? Well, the slope of a vertical line is undefined, right? M is undefined. And since the derivative describes the slope of the tangent line, well, the derivative does not exist there because we don't have an answer for the slope. Okay, so you'll see questions like this in your homework as well. I don't have any examples. You'll just see that there. Okay, that is it for 2.4, a big section for us and a long section. So good work. Check out the homework.